Hello everyone. In this video, we'll provide the training course on AWS certificate for Generative AI Developer Professional, where we'll talk about the implementation and the integration domain, which covers 26% of the exam questions. Here we'll talk about AWS Strands Agents SDK. Strands actually is AWS open source SDK for building AI agents using model-driven approach. It's listed under AWS tools and SDKs in the exam scope, so you need to understand what it does and when to use it. Strands is quite different from traditional agent frameworks. It lets the foundation model handle the orchestration rather than requiring you to build elaborate state machines. The key philosophy is that modern foundation models are sophisticated enough to be their own orchestrators. Rather than writing complex control flow logic, you define what the agent can do from the tools and what it should achieve in the system prompts, and let the foundation model figure out the steps to execute it. This is the model driven approach. The model reasons through problems dynamically and adapts based on what it discovers. Core components of Strands. Actually, Strands agents consist of three main parts. Model provider, which foundation model to use. Strands supports Amazon Bedrock foundation models from different providers like Claude, Nova, Lam, Anthropic, OpenAI, Olam, and others. You can use different foundations model for different agents or switch models without it changing your code. System prompts establish the agent role, goals, and behavior. This is where you guide the agent's reasoning. Rather than rigid control structures, you shape behavior through carefully crafted prompts. So the component is a tool build. These are the tools the agent can use. Tools can be Python functions, Lambda functions, MCP servers, or other agents. Strands handles tool execution and provide result back to the foundation model. The agent loop is straightforward. Invoke the model with prompt and the available tools. The model decides what to do, respond, or use tools. Strands executes any tool calls, and the loop continues until the model completes the task. This is very intelligent actually. Strands supports several patterns for coordinating multiple agents. First one is agent as tools. Treat other agents as tools the main agent can call. This creates natural hierarchies where an orchestrator agent delegates to specialist agents. For example, a research agent might have a specialist agents for web search, data analysis, and report writing. The orchestrator decides which specialists to consult based on the task. Next part is swarms as agent pattern, where peer agents collaborate autonomously. Agents can hand off tasks to each other, decide dynamically who should handle what. This is useful for problems that benefit from diverse perspectives or parallel exploration. The agents self-organize rather than following a predefined structure. نسوى better. Third is graphs, deterministic workflows where execution follows predefined patterns. You define which agent runs next based on conditions. This is similar to step functions, but for agent collaboration. Use graphs when you have clear stage-wise structure and need precise control over the sequence. Third pattern is handoffs. Agents can agents can transfer control to humans when they encounter tasks outside their expertise. The conversation context is preserved so the human can pick up where the agent left off. This is quite useful for human in the loop workflows. Strands integrates with AWS services natively. Like it integrates with Amazon Bedrock, it can use any Bedrock foundation models as your agent's brain. It can integrate also with Agent Core Runtime. It can deploy Strands agents to manage the runtime for production workloads. It uses Agent Core memory for automatic session and long-term memory management. It can use Agent Core Gateway to connect to tools via MCP servers. It can use AWS X-Ray for distributed tracing of agent execution. It can use also OpenTelemetry built-in instrumentation for observability. You can deploy Strands agents in several ways, like as a serverless, as Lambda function, as containers on Fargate, ECS, EKX, or on Agent Core runtime. For production deployment, Agent Core runtime is typically the best choice because it's purpose built for agent workloads. MCP, Model Context Protocol. Strands supports MCP, which is open standard for connecting agents to tools and data sources. There are thousands of published MCP servers that Strands agents can use. Databases, APIs, file systems, web browsers. MCP servers can run in process, same runtime as the agent itself, or remotely on separate servers. Agent Core Gateway can host MCP servers and make them available to multiple agents. This means you can build a library of tools that all your agents can use through the MCP servers. Actually, Strands is particularly good for research agents, data analysis agents, and the multi-step workloads where the exact sequence of operations is not known in advance. The model figures out what to do based on the task and the available tools it has. You would Strands when you want a code first approach for building agents rather than console management. You need multi-agent coordination patterns like in swarms, hierarchies, graphs. You want to leverage the model's reasoning for orchestration rather than writing a control flow. You need production grade observability and instrumentation. And if you are building complex agentic workflows that benefits from model driven approach, we'll compare between Strands and different other approaches like Strands versus Bedrock agents. Actually, Bedrock agents is configuration based. You define action groups in the console, but Strands is code based. You write Python or TypeScript code. Bedrock agents is simpler for straightforward use cases, but Strands gives you more control and supports advanced patterns like swarms and the graphs for agent patterns. Strands versus LangGraph. Actually, LangGraph offers more developer control and the broader ecosystem for integration. Strands emphasizes model-driven autonomy and the production observability. LangGraph is better if you need lots of pre-built integrations, But Strands is better if you want the model to handle the orchestration and you need AWS native deployment and services integration. We will compare between Strands versus step functions. AWS step functions is for orchestrating AWS services with visual workflows, but Strands is for building AI agents that reason, decide what to do. You can use step functions when you have defined the process, but you use Strands when you want the agent to figure out the process. We'll compare between Strands and Lambda. Lambda actually is general purpose compute, but Strands is specifically for building agents with tool use and reasoning. You can deploy Strands agents to Lambda, but Strands provide the agent framework on top of Lambda compute. Actually, in the exam, you should understand what the model driven approach means. Model handle orchestration, the core components, model, prompt, tools, and you should also understand the multi-agent patterns as agent as tool, swarms, graphs, handoffs, and when to use. Integration with agent core services between strands, how to use strands versus other approaches or frameworks. The exam might ask about building agent with custom frameworks. Strands is AWS native option, multi-agent coordination patterns, or deploying agents to production by using Strands and deploying it on agent core runtime. Strands is quite new. It's actually open sourced into 2024 for version 1 in 2025, so the exam coverage might be limited initially. But it's very important to understand modern agent development on AWS and will likely feature more prominently in future exam versions. Thank you guys for watching this video. I hope you like the video if you like the content. And if you have any questions, please comment on the video. And please subscribe to my channel so that you can follow up the next videos we provide on AWS exam. Thank you.